What we want to do today is talk about the software-defined vehicle. I hope you can properly see it. The idea came, or the topic came from the different discussions we have with OEMs, with tier 1 suppliers, ST systems, and we talk about what's next in this whole environment we are in. And you might remember a couple of years ago, we had this the acronym for CASE, Connected, Autonomous, Shared and E-Vehicles, or e-mobility. And it feels like giving all the news we are seeing all over the days, that CASE or software-defined vehicle is now replacing CASE as a kind of marketing slang and marketing term. And the question is this reality, or is it something really different? So what I would like to do today is to say, sort a bit on this area of software-defined vehicle, put it into a context, and look from it from a different angle. First of all, I'm clearly thinking that this is not a marketing stuff and not another acronym. It's really changing the way we deliver services for vehicles, but more services for mobility and for the end users. But let me start from a different angle. And we are ST Systems, an entity of Deutsche Telekom, so we are somehow linked to the way connectivity is provided. And looking in this industry, 10 years ago, we discussed a lot about software-defined networks and network function virtualization, the way connectivity services are provided. This comes especially with cloudification or disaggregation of components, or looking from an architectural layer at the different ways of services, how services are connected. Cloudification 10 years ago might be a broad term, so the real first public clouds were more in place in the 2014, 2015, so really usable in the way that they support development activities and are developer focused. Now the success of cloud coming from developer-driven environments. So everything about software-defined networks is very closely linked to the way how software is developed for this. So what is changing, or this is also developing more and more. Now in the telco environment, this developed from software-defined networks in what is called Open RAN as one area. So RAN is radio access networks. One is the technology between the end user devices and the core networks of a telecom environment, which means hardware, software, architecture layers, connectivity in between. And here we see a strong move with Open RAN into open APIs, separating hardware from software, reducing vendor dependencies and increasing flexibility. Obviously, standardization is driving costs down, and everything I mentioned in the past 1 minute or 2 minutes about disaggregation of contents, architectural layers, open APIs, standards, is the same terms we are using in software-defined vehicle context. So here we see the real, say, development in this area. So we're talking about software and the software continuum between vehicles, edge and backend. And I would raise the point that the software itself is not longer a technology problem. Software-defined vehicle is not a technology problem. We have all the different components available. And with these technologies, we can create stable and well-architected softwares for the different environments, whether it's the vehicle or it's the back end, whether it's the combination of both, where a solution is created by combining both services. So first hypothesis is technology is not a problem. So now let's look where the problem sits in this whole environment. I believe that the main topic of software-defined vehicle is getting the different life cycles together. So we see life cycles from the hardware, from the car itself, 10 years, but not 10 years from now, but 10 years from end of production. We see different R&D cycles, 3 to 4 years for another generation of vehicles and components. We have the platforms, the cloud platforms today, which also have life cycles, 8 to 10 years, service life cycles. You could even argue that a service life cycle is just a release life cycle and can be between days, new fix, feature updates, or maybe a couple of weeks until we have major releases or new services added. So really complete different look at the way life cycles are defined, up to technology life cycles when new technology is coming into action, is introduced to the market. And on top of these different life cycles, we place software, and software which is developed in a very short time, needs to be released within weeks, so quick time to market, but then needs to be maintained for the years. So these different life cycles and overlapping timing events, this is where the main topic of software-defined vehicle will sit in the future. So if it's not technology, what's then the problem, and or how can we solve this? I called it 4 common ingredients. It's not a solution with saying if you do this, it solves you all the problems on software-defined vehicles. I don't believe in this easy solution, but the 4 main ingredients on this slide: the product focus, the output focus, what we call the build, buy, and compose. So how do we integrate things together, and the operations focus. This is how a software-defined vehicle become successful or even implemented in the long run. I would like to go into details on each of them, that you get better understanding what I mean with these different ingredients. So let's talk first about the product focus. I talked about different life cycles, and the different life cycles are sit across the different components, like the platform, like the vehicle itself, like a device, like a piece of software. In the end, we have to see each and every single component in this as a product. So everything is a product with a certain feature set, with a certain roadmap. So we have to talk from feature to version, from version to roadmap. So to make sure that we are not looking into what we deliver the next 2 weeks or the next 3 months in increment, but what kind of feature and roadmap is being committed over a certain period of time, is being maintained over a certain period of time. So the output of what is being delivered beyond the pure coding, beyond the pure development, and beyond it what the DevOps team is doing, it's architecting the outcome, really working with the brands, the markets, the product management on designing this architecture, this result set. It is moving away from the classical split of work responsibilities, RACEs, first, second, third level support in the operations, or product management, development, testing, rollout. It needs to go hand in hand, and this product focus is quite important because it spans across the different components. So this sounds easy, but it is not that easy, because it would require that everyone in this complex ecosystem has the same understanding of the product. You can work with partners, you can use software as a service offerings, you can do everything yourself as an OEM, and we see these different kind of strategies in the market. Partnering is definitely an option, but you need to share the product mindset. So you might have to share the same product vision for the next year. Maybe you have it for 2 years, but I doubt that it's possible to create a consistent mindset across different partners of the components across 5 years. So market is changing, environment is changing, regional regulations are changing, a lot of changes. So this mindset is also then changing and needs to be constantly adapted to keep the commitment. The same is true for to look at managed services, managed platforms. Works very well when we start, can be well defined, and also can get well architect integrated from the beginning. But then you have to manage the change, have to manage everything which you need to develop a fully managed platform into the next generation, adding features. So having the speed of the product focus, not only by a feature set, but by platform focus. And last but not least, doing everything in-house or with a defined set of resources. This means time and capacity and skills. And we all know that especially today, resources are rarely available to hire as we see the demand. Everyone is hiring like hell, and therefore this is also limited. So it needs to be a combination of the different strategy and aspects. But this leads us to basically the second ingredient, as we call it, the output focus. We called it the army of people problem. So you see it also in the news. Everyone is hiring. Everyone is looking for software developers. Everyone is looking to integrate the software engineering lifecycle with the product development lifecycle of an OEM. So this shortage of capacities and skills and upskilling demands will continue to exist this year, next year, maybe the year afterwards. So it's a long-term problem and will not go away. So how can we get out of it? It means we cannot wait for the next 100 people to join, for the next 1,000 people to join, but we have to work with the people and the skills we have today. Of course, developing and do it in parallel, but on the other hand, standardization and using existing commodity software helps a lot to replace the dependency on individuals, dependency on FTEs, on people, in order to support the different deliverables. So with commodity platforms, commodity software, we talk about components which are reusable across generations, across brands, across even OEMs, because they're doing the same. And we have to add only the differentiating parts. The same is true on platform integration. Do not run multiple platforms because it needs a lot of resources to do this in parallel, but focus, integrate into one platform, tools and services. In the end, this means work with the people we have, keep them, of course, but make sure that the outcome is fully managed for the number of people. So this needs a certain structure in delivering the outcome and the output management, and having happy teams to do what they can do the best. It's ultimately important to deliver the right output with the people available. The rest may come on top, may increase it, but if we do not manage the output today with the existing workforce, we will not manage with even more people. And this is true for everyone in the industry. So that was the second one on the output management. The next one is what we call the build, buy, and compose. And you see this keyboard here as an example. This compose tab is available. It's basically standardized back in the 1990s, and it's used to create letters or in your documents which are not exactly on your keyboard. So you can combine different tabs on your keyboard to a new sign. So you compose a new meaning. And this is what we mean with this build, buy, and compose. You buy commodity service is existing there. You build the differentiating part, but in the end, you want to compose a solution. This full focus on I do it myself, I do it from scratch, needs a lot of resources and also creates a lot of, say, technical debts or technical dependencies, let's like this, into the future. So having this kind of composable thinking, composable business architectures, using composable technologies, this is what we recommend in terms of make sure that you focus on the right topics, compose. And an example is what we as systems are calling the hypercubes or the hypercode. So existing components for connected vehicles, for device management, for an over-the-air management, for digital twin, which are supported by the way we implement this for customers, which is called the hypercode. It has a UI component, has a rule engine, has a workflow editor, things you need in different areas of your environment, which are consistent, and you can use them to compose a wider solution for a certain OEM or for a group of brands. So build, buy, and compose is coming from the low code, no code thinking. So that there's no need to code anymore. I think this is, this is far beyond of today's reality, But build, buy, and compose is the right notion when thinking about how to create a software-defined vehicle with different components and bring together what is existing already. And last but not least, an ingredient is on the DevOps side. We mostly look today on dev, so feature output. The more features, the better, measuring velocity. But from this massive dev-only scope needs to be moved also into an operation scope. So from heavy focus on development output, we need to come to a good focus on operations output, and we call it the operate anywhere idea, which means we can and have to operate the software-defined vehicle in any platform, whether it's in-car, onboard, or off-board, so cloud native, cloud agnostic, or in different onboard environments that they still work together across generation, across brands, across regions, but also being able to operate this from a security perspective, from a stability, performance perspective, also from the very beginning, not just looking at feature output, but also how such a feature live in an environment which requires not 10,000 updates a day or 10,000 vehicles to be updated, but millions of vehicles all over the world. And this is why we're looking in this ops part on a very specific way to bring the features into an operational environment. And again, as an example, we see a strong focus on development. So software is ready, software goes into a software repository, and until we release it to a car, we release it into a pipeline, there's a lot of stuff in between, from packaging signing, it's like quite straightforward, into homologation, into virtual vehicle testing, into campaign management. And typically there's still a lot of manual work, approvals, testing activities, which can and should be automated, which can and should be operated to get the developer activities as close as possible into the real deployment of software to vehicles, but also support the people who are going to run these environments. So the after-sales teams, the technical operations teams, call centers who know exactly the status on the software in a vehicle. So you see there's a lot of dependencies, and this can be covered by a developer console up to a vehicle operations center for a consistent look across the fleets. So I talked about 4 ingredients. So and in the end, ingredients is one part, but to make a nice dish, you need a recipe. You need to know how to prepare, you need to know the volume, the amount of ingredients you need to do, and you need to practice the doing. You need to do it on a day-to-day basis. The 4 things are basically looking at the product in a multi-dimensional way. We talked about the life cycles. We talked about the output management. So you have to keep in mind that resources remain limited. So efficiency and output is key. Number 3, the build, buy, and compose part. No one can do everything themselves. So standardization components is key. Thomas will share some insights on the standardization in the open source area in a few seconds. And last but not least, operations is key, because in the end, you can have the best software. If you do not get it out, you can get it operated. The software-defined vehicle will not hit the road, and it will please the customers. So with this, we are sure we will not get software in every car, but we try, definitely. And if we think ahead for a year from now, then I would say we will definitely still look for resources, every one of us. We will have seen most likely the first operational flaws for one of the other OEMs, so pricked cars, delays in software rollouts, whatever. And number 3 is also the fact on the product focus, that this topic of product notion will spread within our industry. So every participant in the industry, every deliverable of services and components will focus more on what a product will look like, so that you can plug this better together, have better understanding. So these are kind of 3 topics for the year ahead. So with this, I'm obviously open for questions.